Okay, good afternoon, everybody. Thank you so much for joining us for the webinar this afternoon. My name is Jamie Burke, and I'm Vice President at Science Buddies. We're really excited to introduce the 2015 Fluor Engineering Challenge to you. Just a little bit about today. I wanted to let you know what this webinar is going to cover. It's the introduction to the challenge itself, and I've had the pleasure of speaking to a number of the participants already via email, and we're really excited that people are taking part in this all throughout the U.S. and Canada. Lots of you are with different after-school programs. With some of you have got a lot of engineering background, some of you a lesser engineering background, and just want to assure you that this is going to be something that's really, really fun and engaging for all of your students. So we will be walking you through the challenge logistics. I'll be walking you through what it means, the fact that you are going to be joining us from one of the 4 Fluor locations that's been chosen as a pilot site. And then Dr. Ben Finio of Science Buddies will be walking you through kind of the tips and tricks for how to implement this with your students, all the sort of specifics about the materials and the judging and how to actually implement with your students. And I can say that I've had the pleasure of working on some technical projects with Ben here at Science Buddies, and he's got a lot of experience in working with kids and sort of translating highly technical information to people like me that are not as technical, and we're really happy to have him and really pleased with the work that he's done on the project idea this time. And then we'll be ending up with what to do next, just the next steps as you implement with your students. So let's go ahead and get started. Wanted to give you this welcome from Fluor Corporation, who is, as you know, the company that we've worked closely with to implement this program. Lisa Proctor at Fluor has been working very, very hard behind the scenes for about 1.5 years now to bring this program to life. Fluor is really committed to getting kids excited about science and technology, engineering and math, and to help them learn about what the career opportunities are out there in engineering. They've been supporting Engineers Week for about 50 years. And as those of you on the call probably know, they really have designed and built some of the world's toughest projects here in the Bay Area where I live. We certainly appreciate the work that they've done on the Bay Bridge through Caltrans. And so internally every year, Fluor engineers have been challenging each other through a company-wide competition. Teams of Fluor engineers have been going head-to-head in this competition for decades. Last year, more than 500 actually, Fluor engineers around the world participated in this internal challenge. And so Fluor really thought about how can we make this something that's fun and exciting for kids around the world to participate in, really pushing it from an internal program to an external program that's going to really get kids engaged and excited. So last year, Fluor's employee competition involved what was called a Moving on the Moon challenge that was designed by their engineers in Houston and inspired by NASA. And Fluor is really now bringing the spirit of this annual employee competition to students. And so it's with help with the team, our team at Science Buddies, that they've taken that Moving on the Moon engineering challenge and really adapted it into an engaging engineering project that we hope that you'll be able to really introduce easily to your classroom or your after-school program in a way that can really bring hands-on engineering to light with the work that you do with students. So just to quickly go over the challenge timeline with you, as you probably know, the window for the challenge opens with the beginning of Engineers Week, which is Sunday, February 22nd, and then the window will close on Sunday, March 15th. We're asking that everybody submits their survey, their results via a survey link, which is available on the local page at Science Buddies. The address for that page is www.sciencebuddies.org/FluorChallenge/local, and you will be able to go in and find your individual location and submit your scores there. Then by Tuesday, March 17th, we'll be notifying all the participants about whether or not they won. And then the winners will be notified with a packet of information. And if you look at the next bullet, we're asking that everybody who was the winner in the 4 locations holds a special celebratory event that will be at their winning school or organization that will be held either Wednesday, March 25th or Thursday, March 26th, You'll be working closely with your own local Fluor office to hold that event, and you will be having employees from Fluor that will come and help and celebrate with your students. So now moving on to the roles and responsibilities of the local organizations. So if you are in one of the 4 locations, that's Greenville, South Carolina, Orange County, California, all of Canada, or Houston, Texas. So your roles and responsibilities will be to complete the Fluor challenge with your students during the challenge window. Next bullet is to really let the world know how your students did. We would love to hear from you and have you engage in social media so that people around the world can see the photos of the great solutions your kids are coming up with, their scores, the interesting solutions that they've created through the challenge. And so Science Buddies does have a Facebook page. You could tweet it out through Fluor, and we've also created a special hashtag Fluor challenge for you to send tweets that way. Next, again, just a reminder to go to the Science Buddies website to submit your scores by midnight Pacific time on March 15th. And then we also did just want to highlight that in addition to competing for the $2,500 local prize in your specific area, your organization will then also be eligible for the $1,500 award that will be made by random drawing from all organizations who are participating in the challenge around the globe, not just people in your area. And you don't need to worry, there's nothing extra that you need to do. By participating and going to that link and submitting your scores for your location, we will automatically enter you into the global random drawing. And then again, if you are the winner of your local challenge, we'll have you partner with your local Fluor Community Relations team in their office to hold a check presentation at your school or your organization on March 25th or 26th. And if you are the lucky winner in your specific area, we'll be giving you a specialized toolkit to help you organize that event and lots of ways to message it to local media. So next slide goes over the toolkit components. All of you on the call should already have the toolkit, and if you don't have that for some reason, again, you are able to download that from the Fluor local website. That's at Science Buddies. Just to quickly go over what the toolkit components are for you. It's got the project overview and the timeline, the roles and responsibilities that I've just gone over here. It's got an FAQ on a lot of the particulars of the challenge to really help you walk you through some of the logistics and kind of the common questions that we think people might come up with. It also includes ideas for social media posts and some great helpful web page links. And then it includes also a sample media release and newsletter story. And we know that you guys are going to want to share the great work that your kids are doing in your local community through your local media, and really encourage you to do that and are trying to make it as easy as possible for you to do so. Okay, with that, I'm going to switch it over to Ben Finio, who is our scientist, our staff scientist, who has created the project itself.
So hi everyone, as Jamie introduced me at the beginning, my name is Ben Finio. I have a PhD in mechanical engineering, but have worked for several years for Science Buddies, creating through 12 content. So I'll dive right into the challenge for this year, which is based on an internal employee competition that Fluor ran in 2014 called Moving on the Moon. It had a bit of a space context to it. The premise was supposed to be that Fluor had been hired by NASA to develop little gas-powered moon rovers that would drive around and run supplies around for a moon base. We pretty much took that competition and modified it to be a little more student-friendly. The employee competition being done by professional engineers actually had a lot of very strict rules and guidelines you needed to follow. So we toned that down a bit to make it more accessible in the K through 12 classroom space. And it may introduce a lot of students to the engineering design process, which is something that they might not necessarily be familiar with. So the basic premise is to build a balloon-powered car from a specific list of materials. So a balloon-powered car, in case you've never seen one, it's kind of similar to a mousetrap car, which is another common science project like this. You inflate a balloon, attach it to a car, which, as you can see in the picture here, has CDs for wheels, and then as the balloon deflates, it pushes air out the back and propels the entire car forward. So if you'd like, this is a good opportunity to teach physics concepts like Newton's laws of motion or potential and kinetic energy. And in the context of this project, the goal is to use a specific list of materials to build your car. So we'll talk more about that in a couple slides. And then have the car carry weights, which are going to be US pennies, from a start area to a finish area. And then there's a simple scoring system that awards points for carrying more pennies and awards points for unused construction materials. So for the materials, again, this was taken from the Fluor Employee Challenge, where they had people doing this all over the world and wanted to make sure it was fair by giving everyone access to the same materials. So you will need to locally purchase materials that meet these guidelines. They're all pretty standard office supply type things. You have jumbo paper clips, you have 8.5 by 11 paper, CDs, balloons, wooden pencils, and jumbo straws. So not regular drinking straws, but these are usually called milkshake straws because they're a little bigger diameter. So there are these specific materials, and then for each material, there is a maximum quantity you can use. So that's listed in a table here and also in detail on the Science Buddies website. And then there is a assigned point value per unused item. So just for the sake of example, say the pencils are worth 100 points each. If you only use one pencil instead of two, then you would get 100 points back for that unused pencil. If you look online, just go to Google Image or YouTube and do a quick search. There are many different types of balloon car designs. Again, this is a pretty popular type of project, but we want to emphasize that you should not give design ideas away to your students. So this idea here is to kind of see what they come up with on their own. And if they haven't done the engineering design process before, to introduce the idea that failure and mistakes are okay. So it's probably very rare for a student to build a car that's going to work perfectly on the first time. It might not move at all, it might fall apart, it might get stuck. But the point of the engineering design process is okay to do that, test, redesign, and try again. We would advise if you see your students really struggling, you're running out of time and the car isn't moving at all, then you can kind of step in to nudge them in the right direction, but don't solve the problem for them. For example, a typical problem is it might be kind of difficult to get these CDs to balance on an axle that can rotate easily, so you want to make sure the wheels aren't getting stuck. One important point we would like to emphasize, so these directions are on our Science Buddies website, but if you go on the website and look at the directions, you will see pictures like the ones on the lower right, highlighted in red on this slide. Those are conceptual examples that do not use the materials that are required for the Fluor challenge. So for example, there you see one there built out of a plastic bottle. Plastic bottles are a very common way to build a balloon car, and the one on the right actually has a big piece of corrugated cardboard, which is not allowed. The Fluor challenge only allows paper. We did that because we don't want to give away design ideas to students who are looking at the website. So kids tend to build what they see. So if you show them an example car like the one on the left, the lower left corner there, which is made out of the pencils, paper, CDs, and straws that are allowed for the Fluor challenge, we're concerned that students will see that and just try to reproduce that car. So that picture on the lower left there is available in this webinar as an example for teachers, but it is not available on the website because we didn't want to give that away to students. So we just want to clarify that. Don't build a plastic bottle car. Make sure you read the materials list and only use the materials that are specifically required for the Fluor challenge. So for the test area, and again, all of these dimensions are on the website. You pretty much are just going to need a ruler or a meter stick and some masking tape. You lay down an area on the ground, and then students have to have their car start in a start area, and the pennies themselves, which are going to be stacked somewhere in the car, have to enter the finish area before the car goes out of bounds. So again, this is all on the website and explained in detail, but it's okay if the car sort of starts to drift out of bounds as long as the pennies cross the finish line, which is what you can see in that diagram on the right there. And the scoring system I mentioned earlier, there is a worksheet, just a simple PDF you can download to have students calculate their own score. So they're going to need to keep tabs of how many of each item they use. And again, this is where I'd say don't give this away to students, but obviously there's benefits to using fewer materials. So if you look at closely at the slide at the beginning that actually had a picture of Fluor employees, if you look closely, you can see that they actually only used 2 CDs. So they didn't make a car with 4 wheels. They just made a little thing with 2 wheels, and that gets them a lot of points back. So you'll kind of want to see if students figure that out on their own and how they can get away with using a minimum amount of material, but you don't want to give that away. And then so you tally up your points for your unused materials, you tally up points for how many pennies you carried, and then you add those two to get the total score. You will find a winner from within your local group, and then Jamie went over the process to then submit your top score to us, and we will evaluate scores submitted from different locations.
This is Jamie again. So now we want to go over what to do next in order to participate. Again, perform the Fluor challenge with your students during the challenge window. Very important that you do it within that window of time. We really want to encourage everybody to reach out to us. We've set up a special email address here at Science Buddies and are pretty good about getting back to you with any technical questions or logistical questions, so don't be shy. Just email us at fluorchallenge@sciencebuddies.org. Again, submit your scores on that local page by midnight Pacific time on the 15th. And then reminder that you don't need to do anything beyond that. Your submission will automatically be entered into the random drawing for $1,500. And then winners will be notified by email on March 17th. Also wanted to just highlight for you a few helpful websites. You may notice on the Science Buddies page, on the Science Buddies website, that there are 2 Fluor Challenge pages, and I just wanted to go through for you what the differences are. So there is a Fluor Challenge landing page that's for the general audience, and that is at sciencebuddies.org/Fluor Challenge. That's for everybody in the world who is taking part in the challenge. It's got a lot of great information there, and it also has got a link to the actual project that you need to do, the project that Ben just went over, the balloon-powered car challenge. And then, as I've been mentioning throughout this webinar, there is a special local page that is for those of you in the 4 local markets, and that is at sciencebuddies.org/Fluor Challenge/local, and that is where you will go if you don't already have your toolkit. You'll be able to download your toolkit there. That's where you'll be able to also access your survey so you can submit your scores. And then also we wanted to just provide you with the Engineers Week website, just because they've got lots of great resources for students. So again, we just wanted to say that you should feel free to reach out to us. We love answering your questions and hearing how it's going from all of you. We wish you all the best of luck. I hope you and your students have a lot of fun doing this challenge, and we really appreciate your time this afternoon. Thanks, everybody.